RF Elements has one patent related to RF, and that is an assertion that with asymmetrical horn antennas, their vertical and their horizontal radiation patterns are the same. So on their data sheets, they only show you one chart. They say it's for the vertical and the horizontal. They only show you one frequency point. In this case, it's 5.6. This is at negative 30 dB detail, which is the same as this right here. So this is also at 5.6, and it is negative 30 dB detail. Only this one doesn't just show you one polarity, it shows you two. So you can see both the vertical and the horizontal here with this computer-generated chart. What's interesting about this is that in order to maintain this fiction, they had to take a screenshot from a computer-generated chart like this, draw it by hand. This isn't accidental, this is intentional. They intentionally reduced the level of detail. They went out of their way to reduce the level of detail in their antenna patterns in order to maintain the fiction. Their horizontal and their vertical antenna patterns are the same. You can see that they're not the same. Why does that matter? Well, it matters if you have stations on the edge of the intended coverage area. So this is supposed to be a 30-degree sector. So we've got 0 degrees here, and then we've got 30 degrees here. 15 degrees on each side would make it a 30-degree sector. So going to the middle of this slice, you can see that it is a 30-degree sector with negative 6 dB, which is this line right here, for one of these antenna patterns, the vertical. But for the horizontal, it is not. So if you were 15 degrees off the center of the beam, you had a station here. For the horizontal chain, you would have, it looks like, about negative 14 dB signal. And for the vertical chain, you would have negative 6 dB signal. So you'd have about an 8 dB mismatch between these chains. And that's why it matters as far as having detailed antenna patterns, is so that you can do proper RF planning and provide better service to your subscribers. RF Elements, for self-serving reasons, omitted this detail. So all WISPs had to go off of is a simple heuristic. These are 30-degree horns, which is not really the case. In this case, you should be using it at 5.6, more like a 20-degree sector, not a 30-degree sector. Even when you're in with 30-degree orientation. So even with 30-degree orientation, you should still treat it like a 20-degree sector. And WISP don't know that because they don't have the level of detail in the antenna patterns that they need. How did we get here? Well, we got here because RF Elements claimed that they're the same because they started with symmetrical horns. So they started with symmetrical horns and twist ports like this. In that case, the antenna patterns really were the same. Just once they copied Ubiquity's asymmetrical designs in 2019, so Ubiquity introduced asymmetrical horns in 2017, RF Elements copied them in 2019. They never updated their marketing materials. They just kept on going with the same nonsense, which was that they had the same antenna pattern, same radiation patterns for the vertical and the horizontal polarities. It's worth noticing that RF Elements sacrificed port isolation in order to get that. So they placed the ports not so that they're isolated from each other, but so that they're going to get the same antenna patterns. So even though you would get less chain imbalance with this, you actually end up with less capacity, throughput, speed, because the vertical and the horizontal data streams, the data streams moving across, are going to interfere with each other. The misleading marketing matters, but how we got here is they started with symmetrical horns. They copied Ubiquity's asymmetrical designs, and then they just kept on going with the same nonsense. Thanks for watching.